Hi guys, this is Arpana from Sri Venkateshwara College of Engineering of Electronics and Communication Engineering. Today I am here to explain about the classification of the signals. Introduction to signal classification. Signal classification is essential for understanding the nature and behavior of the various signals. It helps in the design as well as the implementation of the communication systems. This presentation it will be covering the various classification based on the different criteria. First, what is a signal? So, a signal is a function that will be conveying information about the behavior of a physical system. Signal can be any various forms, such as electrical or electromagnetic waves. Understanding signals is a crucial in fields like telecommunications, audio processing, and the control systems. The first type is continuous signals versus discrete signals. Continuous signals are defined for every instant of time and can take any value, whereas discrete signals they are defined only at the discrete intervals and can represent sampled versions of the continuous signals. The choice between the continuous and discrete signals affects the processing as well as the analysis techniques. So as we can observe in this figure, the A is the figure of the continuous signal and the B figure it will be representing the discrete signals. Analog versus digital signals. Analog signals are continuous in both the time as well as the amplitude, which will be resembling the real world phenomena. Whereas digital signals are discrete in both the time and amplitude. Often they are represented as a binary values like 0, 1. The transition from analog to digital signals will be having a revolutionized many industries. So as we can observe in this image, there is analog versus digital signal in the waveform, whereas these are the sample times for the analog. Digital will be in the binary values, that is 0 and 1. Periodic versus aperiodic signals. Periodic signals they will be repeat at a regular intervals and having a fundamental frequency. Aperiodic signals they do not exhibit any repeating pattern over time. Understanding the periodicity it will be helps in the analysis of a signal behavior in system, as we can observe in the image. Dis- Deterministic versus random signal. Deterministic signals it can be precisely described by a mathematical functions, but random signals they are inherently unpredictable and can only be analyzed statistically. This classification is a vital in the fields like statistics and the signal processing. Whereas deterministic it will be having a mathematical model and the regular pattern, but random signals they will be not having a mathematical model and also the random values they will be having. Energy versus power signals. Energy signals they will be having a finite energy and zero average power over time, but the power signals they will be having a infinite energy but they will be having a finite average power. This distinction is very important for signal analysis in the various application. So as we can observe in this image, there is a energy signal waveform and power signal waveform, and few formulas are listed below. Real versus complex signals. Real signals they will be consisting of a real valued functions and are commonly encountered in practice. The complex signals they will be including imaginary components and are often used in advanced signal processing. So complex representation simplifies many mathematical operations in the signal analysis. Whereas the formula for real signals is x of t is equals to x complexity of t, and x of t is equals to minus x complexity of t. Scalar versus vector signals. So scalar signals they will be having a single value at each point in time like temperature or it may be also voltage, but vector signal they will be consisting of multiple values at each instant like position in a space, and this classification is significant in multidimensional data application. So a few of the examples for scalar vector signals like for scalar it will be having magnitude only, like example speed, mass, volume, time. For vector it will be having both magnitude as well as the direction, example like velocity, weight and friction. Time domain versus frequency domain signals. Time domain signals, these are analyzed based on the behavior over time, but frequency domain signals, they will be representing the signal's frequency components often obtained via Fourier transform. But both representations are crucial for understanding the signal characteristics and the processing. Causal versus non-causal signals. Causal signals, they will be depending only on past and present values, which will be making them realizable in the real-time systems. But non-causal signal, they will be depending only on the future values, which are not possible to implement in the real time. This classification is also quite significant for system stability and also for the design. Whereas non-causal signal, they are the signal that will be having a non-zero values in both the positive as well as the negative time. But a system whose present response depends on a future values of the input, that is also called as a non-causal system. But this cannot be implemented in the real time. Real time versus non real time signals. Real time signals must be processed as they are received to ensure timely responses. Non real time signals, they can be processed with some delay and are often used in batch processing. This choice impacts the system architecture and also the operational efficiency. And there is a differences between real time processing and non real time processing. Real time processing is continuous, it is non continuous. It is also called as interactive processing. It is called as batch processing. It is having a deadlines. It is not having a deadlines. It is having a predictable response time, but it is having a extended overtime period. But real-time processing, it is having with the soft real times missing a deadline indicates that the system is not working at its peak. But in real-time processing, in batch processing, missed deadlines might mean that the computer needs more processing capacity in order to finish the tasks. Bandwidth consideration. So, bandwidth refers to the range of the frequencies in a signal occupies, and it is a crucial for communication system. Higher bandwidth, it will be allows for the transmission of the more information, but it will be requiring a more resources. So understanding bandwidth is essential for both signal design as well as a filtering. Signal sampling. Sampling, it will be involving a converting a continuous signal into a discrete one for the digital processing. The Nyquist theorem, it will be states that a signal must be sampled at least twice its frequency. That means highest frequency. Proper sampling is a crucial to avoid the aliasing and also loss of information. Modulated signal. So modulation, it is one of the process of varying a carrier signal in order to encode the information. Common modulation technique, they may include like amplitude modulation, frequency modulation, phase modulation, but each will be having a unique characteristic. And modulated signals, they are fundamental in telecommunications for the efficient transmission. As we can observe in this image, there is a modulating signal, carrier wave, and amplitude modulated waveforms. Signal processing techniques. Signal processing involves the manipulation and analysis of the signals in order to extract the useful information. Techniques also include the filtering, compression, and also enhancement tailored to specific applications. Advanced processing techniques, they are essential in the modern communication and also multimedia systems. Or applications of the signal classification, it will be playing a critical role in the telecommunications, audio engineering, and also medical diagnostics. It will be aided in the development of the algorithms for the noise reduction as well as the data compression. But understanding the signal types, it will be enhances the system performance and also reliability. Challenges in the signals classification. Signal classification, it will be facing a challenges such as noise interference and also signal distortion. So variability in signal characteristics can complicate accurate classification. Continuous advancements in the algorithms as well as the technology, it may aim to address these challenges. Future trends in the signal classification. So, emerging technologies like machine learning, which are enhancing signal classification accuracy, and nowadays AI is also trending. So, the integration of AI in signal processing is paving the way for intelligent systems. Future research will likely focus on real time processing and also adaptive classification techniques. So, as we come across the image, there are few AI and machine learning trends like generative AI, overlap of AI with an IoT, then transparency, composite AI, algorithm decision making, no code tools, and so on. Then conclusion, effective classification of signals is essential for various class applications across the multiple fields like life sciences, transportation, banking, product designing, healthcare, marketing, national security, and so on. But understanding the different ways of signal, it will be enables to improve design and analysis of the system. So continued exploration of signal classification will drive innovation in technology as well as the communication. Thank you.